Orbital mirrors could flood the night sky with light brighter than the full moon across tens of kilometers. This is Fascinating Frontiers, episode 162. A new study models Reflect Orbital's planned constellation of giant mirrors and finds severe light pollution. One 54-meter satellite would appear 4 magnitudes brighter than the full moon inside its beam. Scattered glow would exceed Moonlight from 14 kilometers away and remain visible beyond 30 kilometers. The FCC has already approved a pilot satellite despite astronomer objections, with up to 50,000 mirrors targeted for the mid-2030s. The work supplies quantitative numbers for ongoing debates over who controls the night sky. Follow-up regulatory filings and ground-based brightness tests are expected next. On a different note, University of Washington astronomers use detailed Hubble surveys to track how star formation is slowing across the Andromeda galaxy. The data reveal a clear drop in the rate at which new stars are being born compared with earlier epochs. Precise mapping of stellar populations across large areas allowed the team to measure the change directly. The findings add to evidence that large spiral galaxies gradually quench their star-forming activity over time. Next steps include comparing the Andromeda results with similar surveys of the Milky Way. Shifting focus to lunar plans, the NASA administrator stated he is extremely confident in a 2027 crewed Artemis 3 landing. Remember, we covered Artemis yesterday. Today's statement directly addresses the crewed landing schedule. The comment came during an announcement for a privately run air and space show at Kennedy Space Center in early November. Artemis 3 remains the first crewed lunar landing under the current architecture. Engineers continue hardware testing ahead of the target window. A new image combining Chandra, Hubble, Webb, and retired Spitzer data explains unexpectedly low X-ray output in the Tarantula Nebula 160,000 light-years away. Young massive stars should heat surrounding gas enough to produce strong X-rays, yet observations show far less emission than models predicted. The multi-wavelength view reveals how the gas is distributed and cooled. The result resolves a long-standing discrepancy between predicted and measured high-energy output. Further modeling of stellar feedback in the region is planned. Italy's largest radio telescope on a southern Sardinia plateau has received upgrades to continue probing fast radio bursts. The instrument's remote mountain location reduces terrestrial interference for sensitive observations. Recent improvements target better localization and repetition rate measurements of these millisecond flashes. The work contributes to efforts to identify the sources and physical mechanisms behind FRBs. Additional observing campaigns are scheduled through the coming year. A single fast radio burst releases in milliseconds as much energy as the sun produces in 3 days, yet the signal arrives from galaxies billions of light-years away. Picture a brief flash so luminous it could be detected across the observable universe. Then imagine riding that pulse as it crosses intergalactic space. Every intervening cloud of ionized gas adds a tiny frequency-dependent delay that radio astronomers measure to map the missing baryons between galaxies. The Sardinia telescope's recent upgrades improve both timing precision and sky coverage, allowing it to localize bursts to within arc minutes instead of degrees. One surprising number stands out. Some repeating sources fire every few minutes, while others appear only once in years of monitoring. The open question is why the same physical mechanism seems to produce such wildly different repetition rates. A NASA WB-557 aircraft flew above thick clouds off Iceland to observe the total solar eclipse. The plane carried Southwest Research Institute equipment that recorded the solar corona in 9 wavelengths from visible to infrared. Flying at 50,000 feet allowed the team to follow the moon's shadow and collect uninterrupted measurements. The dataset provides new views of coronal structure during the brief totality period. Analysis of the multi-wavelength results is underway. The August 10 launch of QZS-7 completed a bilateral program placing U.S. surveillance sensors aboard Japanese navigation satellites. The second sensor adds redundancy and expands coverage for space situational awareness. Japan's constellation now hosts 2 American payloads under the joint arrangement. The sensors support tracking of objects in geostationary and related orbits. Future coordination meetings will review performance and plan additional contributions. Officials and companies at Wallops Island are advancing infrastructure upgrades ahead of a projected increase in orbital launches. The site expects higher flight rates in coming years from multiple providers. Current work focuses on launch pads, payload processing, and workforce facilities. The improvements aim to reduce turnaround times and support sustained operations. Environmental reviews and construction timelines are being finalized. NASA announced a 2-day public event called Max Power for November 7 to 8 at and near Kennedy Space Center. The expo will feature next-generation aircraft, spacecraft, and autonomous vehicles in honor of America's 250th anniversary. Artemis astronauts and the Air Force Thunderbirds are among the participants. The family-friendly program includes static displays and flight demonstrations. Ticket and scheduling details will be released in the coming weeks. Astronomers are using an extremely magnetized star to probe whether empty space behaves as predicted under strong fields. The object's intense magnetism may induce vacuum birefringence, altering the polarization of light passing through it. Observations could confirm or challenge a 90-year-old theoretical expectation. We're not just studying astronomical objects anymore. We're using them to test the laws of nature, one researcher noted. Additional polarization measurements are being collected. NASA opened the 2027 RASC-AL competition for U.S. collegiate teams to propose concepts for lunar operations and technologies. Selected teams receive access to agency expertise, data sets, and mentorship. The challenge focuses on new paradigms that could shape future moon activities. Proposals are due later this year, with finalists presenting in 2027. Past editions have influenced agency planning for surface systems. A new study in the Astrophysical Journal Letters proposes that a microquasar, rather than the Cygnus X star-forming region, powers the Cygnus bubble's highest energy gamma rays. The vast cloud stretches thousands of light-years and emits ultra-high energy radiation. The microquasar model better matches the observed energy distribution. The paper was published July 21. Additional multi-wavelength observations are needed to distinguish between the two scenarios. JWST observations have identified a galaxy 1.3 billion years after the Big Bang that contains 3 supermassive black holes. 2 lie near the galaxy center and are expected to merge soon. The third is more distant and will merge later. The detection shows that black hole mergers contributed significantly to the growth of today's central black holes. The galaxy is one of the earliest known with multiple active nuclei. Follow-up spectroscopy will refine the mass and accretion estimates. The JWST detection of 3 supermassive black holes inside a single galaxy, only 1.3 billion years after the Big Bang, shows mergers were already shaping black hole growth when the universe was young. 2 of the black holes sit close enough to coalesce on short timescales, while the third waits farther out, giving astronomers a rare snapshot of staggered merger events. The infrared sensitivity that revealed these nuclei also opens the door to measuring their masses and accretion rates directly. Follow-up spectra will test whether such triple systems were common enough to explain the rapid assembly of today's giant black holes. How many more early galaxies hide similar multiples? Space companies are applying familiar marketing strategies to downplay environmental impacts while promoting exploration narratives. The approach appears across launch sites, low Earth orbit operations, and beyond. A space economy projected to reach US $1.8 trillion by 2035 provides the commercial backdrop. The study documents how narratives emphasize expansion while omitting effects on Earth and orbital environments. Policy discussions on accountability are expected to continue. Keep an eye on the next round of regulatory filings for the Orbital Mirror pilot as ground tests begin. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at Nera Network. Links in the show notes. One more thing. If you like today's episode, our sister show First Principles Daily is worth a spot in your feed. Reasoning from raw materials, not analogy, on the breakthroughs that actually cut cost. It's one of the NARA Network's daily briefings, all free at naranetwork.com. The Do Positive Pod is the club for people who do something about it. Episodes and the dispatch wall at naranetwork.com, the DP Pod. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.